Hi everyone, let's take a look at how to find not the area of a triangle. We should have already learned how to do that. It's 1/2 base times height. So we'll remind ourselves the base and height are always perpendicular. They always make 90 degrees with each other. So the area of a triangle is 1/2 base times height. We also should have learned how to get a piece of a circle called a sector, like a slice of pizza, in this case a quarter of a pizza, a big slice. What we learned about that is it's our arc degree measurement divided by 360. In this case, there's 90 degrees out of 360 times pi r squared, because that gives us the fraction of, or the percentage of how much we're looking at. So when we have this entire circle, we're really looking at only 90 degrees here. Usually we find the whole sector. So the idea of this is to consider, how do I get this piece that's kind of a leftover? And I mean, a lot of the times when you're finding the little extra piece, it's going to be the bigger shape minus the smaller shape. Now, that's not a guarantee, but it's almost always the fact, because when you have the smaller minus the bigger, you would have a negative shape. So you can't, in real life at this point, we don't use negative shapes, but we do use it in math, and there's dimensions and other things to think about. So when we think of the bigger shape, it's the whole sector, right? And if we had colored in that sector, what do we need to chop out in order to get just that little rounded piece? So one way I could look at it, again, if I can get the whole area of everything, what I can cut out, if you can see me coloring it in, is I'm going to cut out the triangle, right? Then I'll be left with just that curved piece. So if I can find the area of the sector, the bigger piece, and subtract the triangle, cut that out, it's going to give me that piece of a sector that's basically what's in between a sector and the triangle. So what we're looking at is a quarter of the circle, right? We get that as 90. 90 out of 360 is really a quarter. We can reduce it now or reduce it later. So we're going to find the area of the whole sector of this piece. And the radius we would need, the radius is 22. Make sure it says radius, not diameter. So the radius is going to be pi radius squared. I'll put the 22 in. And because we're looking at a piece of the circle, we're looking at 90 out of the 360, which we could use a quarter if we wanted to reduce that now. You can use quarters and halves, are very easy to see. So if I can find that whole area, one quarter of pi r squared, and then subtract the area of the triangle. So when I put in the radius, I know that the base is 22 and the height is 22. Because looking here, the base and the height of this triangle are the radius. 22 here, 22 here. So we really have a base and a height of our radius, which is the same measurement all the way around in the circle. So I'm going to do 1/2 of 22 times 22. So we're taking the larger piece area minus the smaller piece area, and it gives us that little extra left over. So I essentially only need to use a calculator. 90 over 360 means divided. 90 divided by 360 times pi times radius, pi r squared. So 380.1. And that is the area of everything, but I want to cut out this triangle. So I'm going to subtract 22 times half, which is 11, times 22. So 242. When I subtract the difference, I get the little piece left over. 380.1 minus 242. So I get 138.1 units squared. So the idea is, when you have a little teeny piece like that that's left over, we want to take the larger piece, the sector. The sector would be the quarter of a circle minus the triangle. So let's take a look at one more and set that up. You can use other pieces, so we could put something that's not 90, and we can use the law of the sine laws to find the area of that, and then find the area of the sector. So if I really wanted to, I could find this piece, but what we're focusing on first are the easy ones, because 90 degrees we can find the area of a triangle easily. Base times height times half. So technically we could do this with any amount. Let's just give you a quick example. If this was 30 degrees and 10 and 10, okay, we could find the area of the sector, 30 out of the 360, pi times 10 times 10. And then I'm going to subtract the triangle. And I'd need to use the law of sine. 1/2 sine of 30 times the 10 times 10. So we could do that as well. But we're going to focus on the easier problems, on the ones with right angles, because they make it easy to find the triangle. So I'll do a triangle, a right angle. I would like for you to find this little piece here. It'll work exactly the same way. The only difference will be the numbers we plug in for r, for the radius. So I want to find the area of the bigger piece minus the area of the triangle. So we have 90 degrees again. We can put 90 over 360, or 1/4. Pi times 10 times 10. Now we look at the triangle and we have a base and a height of 10. So the area is 1/2 base times height. Remember, it's half of a rectangle, which is base times height. So 1/2 10 times 10. Okay, so that's 50. And we'll just find the rest in our calculator. 1 divided by 4 times pi times 10 times 10. Pi r squared times 1/4. 78.5. So 78.5, take away the 50, is 28.5. So this little piece we're looking for would represent 28.5. The triangle would represent 50, and together 50 plus 28 would make 78.5, which was our area of our sector. So we really want to know the difference between a sector, obviously, and a triangle, and we want to know the formulas. So if you have questions, be sure you ask. A good question helps you not only if you're confused, but to clarify and find the truth. It's not just people who are confused who ask questions, it's wise people who ask questions. People who are smart. And they sometimes, like a lawyer or a detective, use those questions to find the truth or find problems with what their truth or their thinking is. Have a good day.